So this is a very long title, so we will be unpacking it, of course. So let's dive in. So we all know that the AI systems are doing all kinds of predictions, predicting sentiments of a review, objects in an image, or your credit lending decision given your track record. And if you ask the AI why you're making such decisions, one of the simple but earliest and effective approach is to highlight some of the input features. That words in the text, patches in image, or something else, right? So these all are great, except that it is not very uncommon that these important features found by the AI systems can be, well, unintuitive. For example, this is a very, very well-cited paper in the XAI community, LIME, locally interpretable models, right? And in one of the screenshots, given this newsgroup article, you want to decide the topic. Is it atheism? Is it Christian? And the AI says it's atheism because there's words like posting, host, NNTP, edu, and you will say, why, right? What is going on here? And there's no further explanation of why, right? Same thing for other HCI studies. For example, given a hotel review, you want to decide whether this is fake or it is real. And the AI says it is fake because it contains words like Chicago and my and last, or ask, right? And you just cannot help asking, why? What the heck is going on? No further explanations for the explanation, right? So we're at the situation where we have explanations, but we really demand further explanation. And so you might think, okay, this is recursive, right? But this is actually what we do every time. Like since we are a child, we can be obnoxious. We can ask a lot of whys, right? Why the sky is blue? Well, because the blue lights are scattered more. Why is the blue lights scattered more? Well, because of the wavelengths. Why is the wavelength? And so this is actually our pathway towards deeper and deeper understanding of the thing. And this actually happens since ancient times, guys. We're in Athens, right? We have the most famous person in the world who basically tried to torture people with a lot of questions and just encourage you to think deeper and actually gain wisdom. In modern times too, right? There is a formalized method to ask at least 5 whys to get into the root cause of questions. So now, the question is, can we torture AI with a lot of whys, right? So let us play Socrates a little bit, right? So the dialogue may go schematically like this. Why is example X predicted to have label Y? Well, because it has feature F. Why is feature F predicted of label Y? Well, because the feature is highly correlated with the label Y in the data. Why are they strongly correlated with the data? Well, maybe because they're both connected with an underlying phenomena. Why is the underlying phenomena salient in the task? Well, maybe because the phenomena is part of the data generating process. Why is the data generating process the way you believe it to be? Well, at this point, I guess the AI is going to say, the data is given to me. I don't have any idea of what the data is collected using. And so let me ask my domain experts. Now, if you look at this dialogue, what the XAI community can answer with confidence and systematic methods, well, the first one, this local explanation, right, given the instance. Second one, the global explanation, given the data set. Now, I don't have a good answer. I don't think the literature has systematic answers for any of these deeper layers because, well, I don't know. I guess the deeper it is, the more difficult it is to answer. So this is where we want to kind of attack. We observe strong correlation between the feature and the label. We want to dig into where that correlation comes from, right? So it is predictive, meaning it is correlative, but it is unintuitive. We cannot make sense of it. So we just basically did a little attack using a case study. And essentially, we're trying to kind of shine a light onto the elephant in the XAI room. At least a decade has passed in this field. And people have proposing better and better algorithms for generating the first layer of explanation or the second layer, and user studies by asking humans to look at them. And then the studies sometimes find, okay, they are useful, but a lot of times Maybe there are cases where the subjects, the humans, are confused, but there's not a lot of actual deeper investigation into that. So our goal here is to try to shine a light on the elephant here. All right. Now, we did basically a very simple case study, and this was a data set that's used by many other studies. Chicago hotel reviews, 800 real, crawled from TripAdvisor, 800 fake. You can just hire Amazon Mechanical Turkers and pay them to imagine their travel experience and write up a fake review, right? And then we did the simplest thing possible, just a linear logistic regression classifier and then identify predictive words using the coefficients. Now, if you look at the words that are associated with genuine or real, deceptive or fake, you just cannot help asking yourself, why? Why location is indicative of genuine while Chicago is indicative of deceptive? And so I'm sure you're hypothesizing like crazy in your mind. Why is this case, right? Why conference, if you mention the word conference, is going to potentially be real. Whereas if you mention the word husband, it's going to be deceptive. So you're actually having these questions in your mind, but the explainable AI algorithm do not give you a further answer. So we want to do a little bit better than that. And we took the cliche approach nowadays, right? You have a question, you don't know the answer. Who do you ask? Large language models, right? So for us, we want to ask large language models why they think these are the correlation. But of course, we want to make sure that this is not a bunch of BS. So we want to double check by validating that the conjectured hidden phenomena actually is in the data. Now, this is what we did. We just basically prompt the large language model to say, hey, we train a classifier, and these are the predictive words for the genuine and for the deceptive. Can you come up with some reasons for me? Now, the large language model actually very nicely not only come up with reasons, but also group those keywords into little groups and then come up with a phenomena for each group. So for example, floor, elevator, breakfast, coffee, well, those might indicate genuine reviews because they focus on practical aspects of a hotel amenities. And you can also look at the large language model generated explanation for why a review are deceptive. For example, luxury, luxurious, spa, well, they seem to indicate luxurious aspects and high-end services, and that might be suspicious of a deceptive review. Okay, so all those seem plausible, right? Well, because those are large language models, they are trained to be plausible. Now, we want to actually see whether they are anything good. So basically, what we did was we asked two language models, GPT-4o, to predict whether a given review is fake or real, one knowing all this, one without knowing all this. The one that does not know all these phenomena is basically performing a little bit better than random, so 60%. The one that knows these phenomena performed at above 70%, so a big 10% increase in accuracy by knowing this information. And it basically says this information is actually reflecting patterns in the data. So they're not complete BS, right? So we said, okay, it is useful for the LLMs, right? Because it helps them to detect fake versus true. Now, is it useful for humans? Well, we did a between subject study, and we basically asked humans to also learn from these explanations and see whether they are useful, right? So in this training stage, we asked humans to make a selection, and then we show them the AI prediction, the explanation, and explanation of the explanation. But of course, some of the conditions do not show the explanation of the explanation. And then we ask the user to potentially revise their decision if they want, and then give them feedback to say, okay, did you make the correct decision or not? And then in the testing phase, we basically ask them to do the decision without any assistance, just to show whether the explanation actually did anything useful. And of course, we did post-test surveys asking them a bunch of aspects, right? So the short takeaway is that if you decide to explain your prediction without further explaining your explanation, then it is no better than not explaining at all, because it doesn't make sense. Whereas if you further explain your unintuitive explanations, then everything gets better. The learning accuracy is better, reliance is better, perception is better. And so essentially, because of kind of the sense-making process. All right. So the key takeaway is that feature importance is not sufficient, sometimes can be confusing, and we probably want to further explain those explanations. And LLMs could be a way to go. I'm not saying it's the way, it could be a way, right? And that is my talk. Thank you.